Hi, this is our EECS 435 final project. Our topic is chatbot, and we are Chris, Gunwoo, and Hsuan-Ming Chen. So our goal is to build a chatbot, and we plan to do so by using a sequence-to-sequence model using LSTM, long short-term memory. We'll be using Python with Keras using a TensorFlow backend. So before we actually build a model, we have to first decide what data to train on. We consider Reddit comments, Facebook messages, and some online dialogue corpuses. We ended up trying both our Facebook messages and the Cornell movie dialogue corpus. We also had to decide between word or character-based LSTMs. From what we learned, using a character-based model means that we will be dealing with a much smaller vocabulary. The English language only has around 90, considering all the upper and lowercase alphabet and the punctuations. Since it has a much smaller vocabulary, it will require less memory. However, in return, it will need a higher computational cost, since character-based models need a much bigger hidden layer to successfully model long-term dependencies. Now, this makes sense because using character-based models, we have to take into account dependencies between more time steps. Another con with character-based models is that it can spontaneously generate unusual words with some small probability, even with a well-trained model. Now, using word-based models means we'll first have to tokenize our data set. It will also have a much bigger vocabulary since the English language contains thousands of words, meaning that it will require a lot more memory when compared to character-based models. However, it will have lower computational cost. Another con with word-based models is that it's not very flexible when it comes to dealing with new text and words. In the end, we find that our best results comes from using a word-based model based on the Cornell movie dialogue corpus. Now we'll be going over our code.
So now we will do a brief overview of our code. First, we load in the Cornell movie dialog data into our Python Jupyter notebook. And then we parse all the data, and then we pre-process it so that it's easier to train. Here's a sample of what our data looks like. And then we will set up our model. We'll first set up our vocabulary for both our inputs and outputs, find the maximum length of each sequence. Here are some sample statistics. We have 123,000 samples, 36,000 unique input vocabulary words, and 35,000 for the output. And the maximum length is 29 and 31. And here we split the data into training and testing. We have a 10% testing size for our data. Here's where we create the model, such as the encoder, decoder. Here are our statistics. We use our batch size of 64 and use 20 epochs. Ideally, if we had more time, we would train on more data for a longer period of time. Here, this line of code is where we train the model. However, we already trained it and saved the weights, so we will simply just load in the weights right here. Here's a diagram of our model, and here we set up the encoder and decoder. And here is an example of input and predicted outputs.
There were some problems with our model. First, the outputs do seem rather short. And also when we use character-based model, it outputs a lot of gibberish, as can be seen in the example below, a screenshot. There were also a lot of repetition when using our own Facebook messages as our data set. As seen in the two screenshots below, a lot of the output were just LOLs. Now this may be because our Facebook messages basically contains a lot of these kind of phrases. So things we could try. When we're using character-based model, we could have used more hidden layers. It also gave our models more training time in order to build comprehensible outputs. We could also try using a much larger data set containing actual messages with much larger diversity than just LOLs. And also we want to use actual messages because using movie dialogue means our output can seem sometimes too rigid. That's all.